and open to page 8. We said before, or I guess it was up here when we first came in. What do we remember at all about the domain of a function? And it doesn't need to be profound. Its domain is not that much of a stretch or a reach as a topic. Who's got an idea? Anything that they can add about domain? Yeah, it's every x value that you plug in, and you can get out some y value. Some people go through, well, it's the x value, and that's a profoundly lazy and sort of simpleton explanation, because as you're going through and working on it, your domain, you can plug any x value you want into a function. It needs to also, they'll give you an output. You can plug a 0 in, but if you're dividing by 0, you're not going to get an output, and therefore it's not part of your domain. So that's the main thing for today. We're going to do a little bit of review on inverses. And then after we get stuff done with inverses, we'll talk about going through and restricting our domain. Understand that the problems when we talk about the domain issues, they're sort of next level, higher than normal high school problems. We'll show you the type that you're going to get, and then we'll see the ones that like you'd actually get in a normal classroom. We'll start off, though, talking about the inverse of a function. Who remembers how you can answer any of those three? How would you find the inverse if I give you a relation or a set of points? How would you find the inverse if I gave you a graph? Or how would you find the inverse if I gave you an equation? Who remembers anything about finding the inverse for A, for B, or for C? We've got 1, 2 of us. This was a full part of a unit. We've got 4 now, 5, 6. Brooke, C, what do you want to say?
The equation, you have to show your x and y, and then you have to split them, and then you have to solve.
Perfect. So I go through exactly what we just said. Make sure, 1, that you show x and y. Step 2 was to go in and switch x and y. And 3 was solve for y. What about either of the other two? If I give you a bunch of points, how could we find our inverse? Or if I give you the graph? Yeah, so we should recognize, hopefully, if the original contains the point A, comma, B, the inverse would contain the point B, comma, A. And how about if we're finding the inverse of a graph? Yeah? Yeah, you're going to reflect over the diagonal y equals x. So those are the main 3 things that you need to make sure that you're good at. We're talking about the inverse. For that first one, and also that notation that the f with the little -1 after it means the inverse. This is another part of what we talked about. In order for the inverse to be a function, what do we need to have about the original in order for us to get an inverse that we can use f -1 or f inverse on? What do we need to remember about that? Carly, remember? What does it mean if a function is 1-to-1? Yeah, so we need to have the f of x must be 1-to-1. Which means it's going to have to pass the vertical line test and a horizontal line test. If that's the case, you would know that the inverse would pass the vertical line test without finding the inverse at all. And we even talked about it. You just said what's not going to be a function. Or sorry, what's a regular function everyone's probably super familiar with that would have an inverse that's not a function? Yeah, parabola, and that's the very first one we're going to look at. Your job is we're giving you this f of x, and we're putting a domain restriction on it. Your job is to determine what's the inverse of this, given we're working with y equals x squared And if you need to see a picture of what that looks like, understand it would look something like this. This, we got y equals x squared would look something like this. This, as it is right now, does not pass the horizontal line test. The horizontal line would touch the graph twice, which means the output value of, now in this case it would be 1, 2, or 3, happens twice. You get these output values twice, which means if I took the inverse of this whole thing, it would look like that. That's not going to be a function. But it goes out of its way in the beginning of the question to say, I'm looking at y equals x squared, but I'm only looking at some x values. The ones from 0 going up. So is that the left half of this parabola or the right half? Take a look at what's there. And Lyra, would you say I'm looking at the left half and taking its inverse, or the right half and taking its inverse? I go through, the x has to be bigger than or equal to 0. Yep. So it's going to have to be the right half. We're going to, even though this function is defined everywhere, we're only looking at the right half of it. And the reason that we would only be looking at the right half of it is because if we look at the whole thing, is the inverse going to be a function? If you look at the full graph of y equals x squared, that wouldn't be. Would this have an inverse that's a function? Yes. And so now we're going to find what that inverse is algebraically. So to start, it's going to be y equals x squared. Now the next thing we would need to do, Danny, is what? Okay, so what would you write out? And now from here, our job is to get the y by itself. So Griffin, what would we do to get the y by itself? So now, normally, and this should be on your paper, the inverse should be looking at the plus or minus of radical x, which means I'm graphing the positive radical x, which would look like this, and then the negative of radical x, which would look like that. There's two equations there. One's positive radical x and one's negative. Now, when I'm looking at that, which piece do I need to keep? This is y equals positive root x. This is y equals negative root x. I don't need both of those. Which part can I get rid of? Because it wouldn't be the inverse of the indicated graph. Look at it. What do you think? Yeah. So if I get rid of the negative one, is the purple graph, I think that's, yeah. Is the purple graph the reflection of the black graph over the line y equals x? So which part do I need? Do I keep the positive or the negative when I give out f inverse? Positive, yeah. We know f of x is equal to x squared, and therefore we restricted the domain, so the x has to be greater than or equal to 0. Then we know if that's the case, the inverse of that is the square root graph. And you would have a domain restriction on that, by the way, also because it's a natural domain restriction. What numbers can we not plug in right now for x and get an output? Any negative number, in case you didn't realize that we haven't specified negative radicals yet. It's a problem that we will encounter at some point, and we're sure that there is an actual way to do it. But as of right now, you don't know what we're doing. Do we have questions on how to get to here? You've got that domain restriction. That means you're probably not working with a full graph. Go in right now on your own and answer out the next prompt. Well, Sean, what would you do to start this off? Okay, so I'm going to write this out as y equals 1/2 x plus 3. Keep going. I want to do something first. Switch the x and the y. So this is x equals 1/2 times y, and then plus 3. Keep going. Now what would you do? So x minus 3 is equal to 1/2 y. And what would you do from here? Please, if you see the fraction, how many of you are tempted to say divide by a half? That shouldn't ever be a thing, like you never divide a fraction really by a fraction. When you get rid of the 1/2 in front, you've got to multiply both sides by a 2. So how would you define f inverse then, Sean, what would your final answer be? Careful. Multiply by 2. We can give it out as 2x minus 6 or 2 times x minus 3. Either one of those. Do we have any questions on that part? If we graph it, these should be reflections of each other over the line y equals x. These are ones that are going to be a little bit more difficult. And just so you're aware, the last 3 times that the state has asked this question on the exam in June, it looks like this. So I'd make sure that I was incredibly good at recognizing this patterning. And the way to recognize that this process is going to be a little bit more difficult. Look at the original. What's going to be difficult or different, I guess, about this equation as opposed to some of the others that we've gone through and dealt with? What's different, awkward, weird about this? We got one person to yeah, there's 2 x's, which means when you take the inverse, how many y's are there going to be? 2 of them. Anybody remember how we did these questions before? Remember. All right, let's get started. What would we do, Julian, to start finding the inverse of this? Got to have something before I do that. No. Need to replace the, you said switch the x and the y, what don't have right now yet? What's the f of x equal to? Yeah. So let's put y over 1. If you need it, I like to keep my y as a fraction, the other side as a fraction. So now I get to this step, and now once I got to here, I'm going to switch my x's and my y. So I get x over 1 is equal to y minus 1 all over y plus 5. What can we do, Johnny, to go forward from here? So now I've got 2 y's, and our job is to get the y by itself. Even getting it out of this form might be helpful. What do you want to multiply? Well, how can I give, if you have 2 fractions like this that are equal to each other? Right now, this notation is not our friend. This isn't helpful to us. There's lots of fractions. They freak you out anyway. How can I get this so it doesn't look like a fraction anymore? Yeah, so we're going to cross multiply, take the cross product. I'm going to drag it up and over to the side. I don't know how much space you have. So I write out x times the quantity of y plus 5 is equal to y minus 1. And you can distribute out. So you've got xy plus 5x equals y minus 1. Our problem as it is right now is that you have too many y's. How many y's do you currently have? 2. And your job is to get 1 y all alone. So how can I work to make that happen? Maras, you know what I could do to make it so all my y's are at least 5. If I divide both sides by an x, we lose a variable here, and it's come out over here. That's not going to help us, though, get rid of either of the y's. When we've got 2 of the y's we're trying to deal with. So let's put the y's all together and everything else on the other side. So I've got minus y here. I'll bring this over, and I'll minus a 5x and bring that over. So if that happens, our goal was to get at least the y's together. So we've got xy minus y, not like terms, and then negative 5x minus 1. Don't be afraid of the negative. And he told us what to do, but I didn't harp on it. Look at what's there now. Your job is to get the y by itself. How many y's do you still have? 2. We need to have how many? 1. How can I go from the current notation that has 2 y's in it into a form that would only leave me with 1 y? Factor a y out on the left side. So, or undistributed, if that's how you need to think of it. as it stands right now, when I undistribute that y, I'm just rewriting what's there. I don't change the equation at all. I'm just going through and undistributing a y from the left half. And if I wanted to distribute out into the same these as above. What needs to get done from here in order to go from this form into what our inverse should work out to just. So now when I do that, I'm left with a single y equals, and I'd say in this case, was it f? What did we name this function? Is it f? The inverse function would be negative 5x minus 1 all over x minus 1. You have questions on that part? By the way, what number could we not get an output for in this inverse function? I can plug pretty much any number I want in. There's only one number, though, that I'm going to tell you that should be painfully obvious, that you cannot plug in to the inverse. And that number would cause a massive problem. It would lead to us inputting a value and not getting an output. Well, why can't I plug in a positive 1? Hands up, please, when you can tell me why 1 is excluded from the domain, why I can't plug 1 into my inverse. Yeah, we have an undefined expression. What number is not in the domain of the original f of x? Hands up, please, when you can tell me what number would not be in the domain of the original function, the f of x. Negative 5. Every other number gives you an output. The output might be weird, it might be ugly, it doesn't matter. If it gives you an output, it's part of the domain. I can't plug in a negative 5 in the original, so that's a domain restriction on that. There'd be a domain restriction over here. I can't plug in a 1 because our value would be undefined. Going right now and determine g inverse of that particular g of x right now on your own. Is this one you got? Yes or no? Just so you know, those are the questions that you're going to expect on your exam, and you're a little bit beyond maybe the one, but it's not undoable. Take a look, I guess, back at the original. Who can tell me what the domain would be of the g of x? Think about it in terms, we'll give it out in integral notation. What numbers work for the domain of the g of x? It would be negative infinity to positive infinity. It's a value that we can't go through and get. Think about how our interval would look if we can't go through and get this value in our domain. And it's easier first to just say, well, what's not in the domain, and build out what is in the domain. Close. We've got negative infinity up to positive 2. Now, do you put a bracket or a parentheses at the 2? Okay. Why? You can't plug in a 2. Why is that not the complete answer for the domain? Yep. Why can't, what still needs to be added to it? You're not wrong. We can't include the 2 because it causes our denominator to be 0. But this isn't our domain entirely. It's close. It's half of it.
You have to go from 2 to approximately infinity.
Yeah, it's the only value that isn't going to give us an output is positive 2. Everything else works. So it's every number from negative infinity, except I've got to jump over what number? 2. Everything else works. What happens if I plug in a 5? Will it give me an output? Yeah. Does it matter if it's some weird, awkward fraction? Not at all. By the way, what would our domain of G inverse then be? Take a look at what's there. What would our G inverse domain be as an interval? Similar to the one from before. Yeah? Yeah. And then? Now, by the way, will these always have the same denominator? Wait a minute. Oh, perfect. This worked out to be the same as the original. And I think that has to do with the, go in and see. You could go in and graph out. I'm interested to see what that original works out to be. Do you have it? If you signed in your calculators right now, right? Yeah. So let's have you all do this. Go in on your calculators and graph that out. Let's get what that's going to look like. Because it sort of doesn't seem right that the original and the inverse would work out to be the exact same thing. Especially if you're not working with the identity function. I do think I made a mistake anyway, but I put it. Go in, clear out what's there. We need a new doc. It's a calculator doc. Or sorry, graphing doc. I'm sorry. And on there, plug in what was the original, and then the inverse. And you know what I think? So plug in, what was our, well, the original and the inverse are the same. Was it 2x plus 3 over x minus 2? Okay, so if you control the div, start plugging that in. And then don't hit enter on here, just arrow down. And now plug in y equals x. Now, this doesn't look like it's cutting it directly in half. Why is that the case? Take a look at your window. This is a 10 by 10 window. No. If we wanted to, you could sort of normalize it, because right now it kind of looks extended out. I guess if you want, you can do that trick where you just change it right on this page. You can also go into Windows settings. Pressing Tab, if you're doing that, makes it so you can just start bouncing around, not as fast. Now, if you go through and look, we can even check, I think, if you look at the points. So go into the table. We'll go through and see points that are on there. We should see other points. So let's say negative, when I plug this in, I've got, and I'll go back over here, I've got the point 1, negative 5. So what other points should be on this same equation? We've got the point 1, negative 5. What other point should be on there? So go down to negative 5 and see if negative 5, 1 is on that graph also. Was it? So wait a minute, did it seem like we did something wrong? Like that our original and the inverse that came out to be the same. That seemed a little weird. Was it weird? No. Did we do anything wrong? No. And how could we check to see if we did that? Well, you have to A, understand the inverse, and B, understand how to go through and graph. Is this tough for us? No, I don't think so. Let's go over. We got a couple more. Read that next prompt, and hands up, please, if you can tell me what you think we would want to do if your task is to determine what f of 2a is, given what that f of x is. And you think you could go through and get an answer to that. Jackson, what do you think you could do?
So you put a 2A in for all the X values.
Yeah, so f of 2a means I'm going to replace every input or x with 2a. So this will be 3 times 2a being squared plus 5 times instead of x now, I've got a 2a and then minus a 2. All right, let's clean that up. Sierra, what's some math that you can do on this? And what do you get when you do that? Close. Yeah, sorry, just do the squaring first if you want. So this is 3 times 4a squared now. What else could you list out? That's going to give you how much? Great. And then? So final answer would be what? Is that a lot for us? Okay. Take a look at the next one. It says to go through and take f of x plus h minus f of x for that same equation. What could we go through and do, Joel, to go forward here? Okay, and what's f of x going to be? So, if you want, understand, and some of us really don't get that notion. F of x is what's on your paper. That's the given prompt. You don't need to do more work for that. That one's okay. Even if you have like f of z, or f of c, or f of a, all you do is replace all those variables, but it's pretty straightforward. What do we have to do for that first part, Joel? Yeah, so this is going to become 3 times x plus h being squared, plus 5 times an x plus h, and then minus a 2, and then minus whatever the f of x is. And it's minus all of f of x. I don't know, I got yelled at before because I think I used my brackets, like out of order brackets. They're supposed to be like secondary parentheses. Like, I like them because visually they do a really good job of containing stuff, so to build the box around the math you're supposed to do. The right side, all you need to do is distribute out a negative there. The left side has the actual math to go through and do. So the first thing, I guess, if I had to clean up this business in the first set of parentheses, brackets, Ryan, what would you go through and do to work forward on this on the left? So go through right now on your papers and square the x plus h, multiply it by itself. And also, just so you know, technically those brackets don't need to be there on the first set. I put them there just so you could see this is the beginning part, the f of x plus h minus, and then the other brackets are the x of x. What do we get when we take x plus h squared, multiply by itself, combine like terms, etc.? Tyler, what is that going to clean up to be?
X squared plus h squared.
Close. You got to write it out times itself. You can't just square the two parts. It's first, outer, inner, last. So you need to do x plus h times an x plus h.
Yeah. So it would be x squared plus 2xh
Good.
plus h squared.
Good. And now to that, I'm going to distribute out the 5, so plus 5x plus 5h minus 2, then minus 3x squared. Now I'm distributing out minus 5x and plus 2. I've got one more thing to do, and that's distribute out a 3 in the beginning. And this might look like a mess, but it's going to clean up kind of nice for us. This is plus 6xh plus 3h squared plus 5x plus 5h minus 2 minus 3x squared minus 5x and then plus 2. What's at least a little bit good about what I have written so far? Hopefully you notice anything as you were right now. Can you see anything about what we've written out? Yeah, and what are the like terms you're sort of happy to combine? Or them? Go on. What else do you want to go through and careful. I can combine what?
Oh, nice.
Good. Those are now gone. What else can I combine? So now all of those like terms are gone, and you're going to actually notice something about what's left. You're now left with 6xh plus 3h squared, and then plus 5h. Is that it? Is that right? And by the way, what do all of those have in them? That would be a GCF. Hopefully not too difficult for us. Do we have questions on those? We're going to try a little bit of domain restrictions and domain practice. You talked about what your problem areas are going to be already. One equation that we're going to go through and work with, the easiest one is dealing with undefined fractions. So if I started telling you the original was the function 1 divided by x, what would our domain of this function be? That's the generic parent function. If I'm dividing by a variable, 1 over x, what would the domain of that be in integral notation? We've done one similar to it. We'll think about what the domain won't have in it, and then build up what the domain would be. We've got 3 of us now, 4. Take a look at how you've done it. If we did 2 like this before, we talked about it with our inverse problem as well. What would the domain on this be? In any way you'd like to say it. You're indicating what value cannot be in the domain. Yeah, we know that the x cannot equal 0. That would cause you to have an undefined fraction. The only problem happens when the denominator cannot equal 0. Do we have questions on that part? Next one up is when we're dealing with radicals. If I gave you the square root function and said f of x is equal to the square root of x, and asked you to think about what the domain of that would be, think about the inputs that you can plug in that will give you an output value. Looking at what's there, who can tell me, not even what the full domain is, just tell me a number that would be in our domain. What's one number? 1 is in the domain. 49 is in the domain. 300 is in the domain. Now who can tell me some numbers that would not be in our domain? -5 is not in the domain. What else is not in our domain? -3. Any negative number. Now comes the most awkward part of all. What number are you probably think you've got an idea about, but definitely aren't 100% sure on? Who can think of the number you go, I think I know what this number is, but I'm really not sure about. 0. Is 0 in the domain? Well, can you take the square root of 0? Or can you determine a number that times itself would give you 0? What number times itself gives you 0? 0. So if we're going to go through and we're going to list out what our domain in this case is going to be, I'll give it out as an interval. If we say it's from 0 out to positive infinity, and infinities always get parentheses, just so you know. And also, I write infinities, but any of your computer math works, you don't need to put the plus sign in. Does the 0 get a bracket or a parenthesis? What would you say? It's going to get a bracket. We'd also say, if you wanted to give it out another way, x is greater than or equal to 0. And in general, what you need to have is your radicand needs to be greater than or equal to 0. Radicand is the expression under the radical, not the radical entirely. The radicand is the expression under the radical. So I take the radicand and make sure that that was greater than or equal to 0. The last one we're going to have to deal with is, what do you do with both? So who can tell me a number that is in our domain? Take a look at what's there. And hands up, please, if you can tell me what number is in our domain. Any number you want at all. 1 is in our domain. 2 is in our domain. 1,000,000 is in our domain. What number is not in our domain? Give me a number that would not be in our domain. We got 0. What do you want to say? -5. Any negative numbers. Always begin a debate now with 0. You wanted to say, before when we had the square root, we said 0 was in the domain. And it is in the domain of the square root. Why would the domain of this picture, or sorry, of this equation though, be slightly different than before? Why? Why does it equal 0? There you go. You get 0 as an output from the radical. What's the square root of 0? What does it equal? 0. It's a number. Don't get confused. You can get an output from it. Why don't we include 0 in the domain of this when we did in the example above? Because that 0 that gets spit out gets put where in the fraction? The denominator. So if this is x, and if you want to, you could say your domain is also just x is greater than 0. This case, I would set my radicand to be greater than 0. Not equal to, because if it's equal to 0, you get out of 0, and then that number is going to go through and cause an undefined fraction. Take a look. We're going to try to give these all out in interval notation. Hopefully this isn't too tough for us. Take a look at question number 1. Y equals, or f of x equals 3/4 x plus 5. What's the domain on that going to be? We don't need to tell you this. What inputs produce an output? Linear function. Linear definition. Yeah. Is it possible to not get an output from that, Sean? No. No. Our domain would be from negative infinity to positive infinity. Everything works. What about in question 2? G of x. What would the domain of g of x be? Harlan, what do you think? Same thing. Are there any inputs, any problem times that you wouldn't be getting an output? No. How about next one up is, I think, the quad. X squared minus 3. What would the domain in number 3 be? Think about the input that you can plug in. Think about the graph, any jumps or any discontinuities that you have in the graph might be indicators of domain problems. What do we think, Dale, our domain would work out to be in 3? There's nowhere that these can go wrong. So everything works. What is 4 telling you to go through and graph? Forensic? Yeah, it's going to be an absolute value function. If you need a reminder, an absolute value function is going to look kind of like a V. You go through and graph it out. What would the domain of the absolute value function in front of you be? Hannah, what do you think? Yeah, negative infinity up to positive infinity. We're not dividing by 0. There's no radical. If we don't have that understanding, we need to make sure we get it pretty quick. Inputs that give output. Now, this next one's a little bit more awkward. We're going to have a little bit of a problem. This one's not in our domain in 5. Any other numbers we need to not include. So, what would our domain be? You know that x can't equal 4. Not including the 4. Questions on that one? Right. What about in the next question? In 6, Brenda, what do you think? This might require some work also. What would we need to do to figure out, is it possible or are there any domain restrictions on it? Yeah, you're going to have to find out, why did you say negative 2.5? Yeah, you're trying to cause what to happen with that number you gave. Yeah, we need to make sure that our denominator is not 0. So I need to say 2x plus 5. I put it down as equals 0, and then just remember to exclude that at the end. This is finding the value that throws everything off. I'd subtract the 5 and divide by 2, so we know that the excluded value is negative 5 halves, or negative 2.5. And if you were to give that out as an interval, everything works except for that number. So it would be from negative infinity up to negative 5 halves, not including it, and we skip over it, and then resume after negative 5 halves, going forever in the other direction. We have questions on that one. So you could give it out as a negative 2.5 if you want also. No. Don't use mixed numbers. We're not sure. Take a look right now at 7. Go in. There are multiple values that you cannot go through and arrive at, or not include in your domain answer in 7. Go through right now, apply your process, and see what values you would exclude. And once we have those, we'll work on building up our interval. Take a look at what we did in the last prompt on how to go through and find our domain restrictions. It's very possible for us to go through and have an undefined fraction here. Find the values that cause my fraction to be undefined, and then we'll exclude them. We're looking at what's there. You want to go through this? Yeah, you're looking to find out when the fraction is equal to 0. You don't want that. So find out when that happens, which means you would do x squared minus 5x, make that to be equal to 0. This is actually a super easy plot to solve. What needs to get done from here to work towards giving us a solvable quadratic? Yeah, take out a GCF of x, and what's left after you take out that GCF there? And what would you do now? We have two factors. Our task is now to solve for when both of these factors are equal to 0. So that means I'm going to get two answers. One's a 0 and one's a 5. What would our domain have to be? Well, our domain is everything but those two values. We know our domain is not going to include, or x in this case cannot equal 0 or 5. That needs to be excluded from our domain. If they cause our denominator to equal 0, you can see that from up above in the algebra in front of us. How could you give that out as an interval? You know what that would look like as an interval? And then there's a substantial number of you who are going to miss this middle number, this middle interval. Is 1 in the domain? Could I plug in a 1 and get an output? Yes or no? What about 2, 3, 4, 4.8, 4.9, 5? Make sure you recognize that. That means this middle interval needs to be here. If you leave it out, there's domain values that you're choosing not to include. Do we have questions on that one? A couple more. Take a look at 8. Now, 8, we don't need to be worried about things being undefined, meaning division by 0. What do we need to worry about in question number 8? Look at the structure of that. What's the problem area? When am I not going to be getting output values for these domains? Perfect. My radicand, the expression under the radical, can't be negative. Can it be 0? Yeah. So let's take our radicand, in this case, I minus x. Don't strain yourself. Go down if you need to. That needs to be what compared to 0? Greater than or equal to. So now you have an inequality. It's going to be tough. I'd want to go through Danny, are you ready? Okay. If you had to solve that inequality, what could you go through in this? So if I add an x to both sides, I get 10. Ready? Bigger than or equal to x. Tough. What is that as an interval? Take a look at what's there. Think about the numbers that go through and work. What would this be as an interval?
Negative.
So that means any number less than 10 is going to go through and work. You can plug a 10 in there also. Think about that. What if you plug in a 5? Is that going to give you an output? Yes or no? Is 5 going to let us get an output? Yeah, if you use square root of 5. What about if I plugged in a negative 40? If I plugged in a negative 40, what kind of radicand am I going to get? A positive one or a negative one? Because it's 10 minus negative 40, two negatives make a positive. Go through right now, please, and try out 9 and 10. Right. Mine is done out for you. You get that our critical value is at negative 3. Anything bigger than negative 3 works. Do we have questions on that one? All right. Yeah. How many do we have on there to finish up? Yeah. So here's what I'd advise you to go through and do. Circle for us. 10, 12, 14, and 15. Sorry, I took 10, 11, 12, 14, and 15. How many total questions is that? Do you think you can handle that? I don't know. And by the way, what's due for us on Sunday? Yeah, your weekly study. By the way, what's going to also be posted for you on Sunday? Your next weekly. Everything. That's the name. Make sure, please, that calculators get put back over on the side.